Welcome back to our lesson practice for chapter 3. Today we're going through lesson 10, which continues to talk about division. This time, though, we are going to be using long division to help us divide polynomials. We are still at the point where we are given kind of the factor and told what we are going to divide by. And so as we go through here, we're just going to be using what we know about long division. It just becomes a little bit more complicated because we are dealing with polynomials. So number one, a student tried to divide these two polynomials, circle the mistake, and then show or explain how to fix it. So in this one, as we go through, kind of my steps here are we're checking for how many times x goes into x cubed. So x times x squared is x cubed, which is great. So we multiply x plus 2 times x squared, which gives me this in parentheses here. And then we subtract. So we get 0, which is good. Then we do negative 6x squared minus, because there's a minus right here, 2x squared, which gives us negative 8x squared. And then we bring down the next piece, negative x. And so I'm going to erase the colors here to kind of catch back up. We're trying to see how many times does x go into negative 8x squared, or what do I need to multiply by that, which is where we get negative 8x here. I multiply negative 8x times x plus 2, which gives me what's in parentheses here, negative 8x squared and minus 16x. And then when we subtract negative 8x squared minus a negative 8x squared, remember when we subtract, we are really adding a positive there, which gives us 0. Negative x squared minus a negative 16. So it looks like this is where the mistake is, because negative x minus a negative really should be adding, which would then change this to positive 15x plus 30, which changes the last part of this problem here. So to kind of change what this would end up being, so everything looks correct up until this point right here, where I'm going to cross this out, and instead I'm going to make that 15x plus 30. And then I'm going to see how many times does x go into 15x, or what do I need to multiply, which would just be positive 15. And then we multiply 15 times x plus 2, which would give us 15x plus 30. And then when we subtract that, we get 0 and 0, meaning we don't have a remainder in our solution. So our final solution really would be x squared minus 8x plus 15. Problems 2 to 4, fill in the missing number. So when we're going through here, we're really just kind of working on factoring a little bit. So in this one, since we're pulling out an x squared, what I'm going to see step by step here is when I pull out the x squared, I get x squared minus x minus 6 remaining. And so then I'm going to be factoring what's left in these parentheses here. First term, first box, last term, last box. Negative x gets split up into two things that multiply to negative 6x squared. So I got negative 3x and 2x. Figure out what goes on the outside of the box here. Sorry, it's a little bit small. But we end up seeing that we get x plus 2. So going back up to my answer here, and x minus 3, which is what this factors into. For number 3, we are first going to take our original part here and divide it by 2x plus 4. I'm going to go ahead and practice this with long division here, and then we will see what we get, which looks like is going to factor into something else as well. So let's rewrite this here. We'll go 2x plus 4. How many times does that go into 2x cubed plus 14x squared plus 8x minus 24? All right, let's get a little bit closer in on this. First step here, what do I need to multiply from 2x to get to 2x cubed? Well, that would just be x squared. X squared times 2x plus 4 would give me 2x cubed plus 4x squared. Change color, subtract all this. This becomes 0. 14x squared minus 4x is just 10x squared. Bring down the rest. I'm going to bring down the negative 24 too, even though it won't really matter until later, but I'm going to go ahead and do that. The next thing I need to do is I need to check 2x over here multiplies by what to get 10x squared? That would be 5x. Multiply 5x times 2x plus 4 to get 10x squared plus 20x, and subtract all that. Again, remember to put the parentheses here so that you remember that you're subtracting each term, so that when we do this first one, we get 0, which is good. And then when we do 8x minus 20x also, we end up getting negative, 12x. Now we bring down the negative 24. I'll switch colors. 2x times what is negative 12x? That would be negative 6. And then negative 6 times 2x plus 4 becomes negative 12x minus 24, which is good because when I subtract that, this becomes 0. Negative 24 minus negative 24 is also 0, which means I have no remainder. And so really what this ends up becoming, let's factor it. So we got 2x plus 4 in parentheses, and then we're left with x squared plus 5x minus 6. And so now when we're trying to finish number 3 here, what we're trying to do is this x squared plus 5x breaks up into 2 pieces, it looks like. So I'm going to use my standard box and diamond, first term, first box, last term, last box. 5x needs to be split up into 2 things that multiply to negative 6x squared, which would be 6x and negative x. And then figure out what goes on the outside. And then that tells me this has to be 6, and this has to be x minus 1. Number 4, we got same idea here. We are taking this first one here, and we know that x minus 1 is a factor, so we're going to go ahead and do the division for that. Let's see if I have enough room underneath. I may regret this, but let's try it anyways. Sometimes finding enough space for these problems is always a challenge in this book, but hopefully, if you need extra paper, you're always willing to go grab it. Luckily, I have the whole infinite space over to the right here, but it just gets more confusing the farther away I get from the problem. So I'm just gonna have at it right here. So first thing, what do I need to multiply by x to get to 6x to the power 4? That would be 6x cubed. And then I multiply minus 6x cubed. And then I subtract both of these. The first one becomes 0, 6 minus 6. Negative 2 minus a negative 6. This ends up becoming adding for that one, which would be 4x cubed. And then I can bring down the rest of this here. So bring down, bring down, bring down. Negative 14x squared plus 2x plus 8. Next thing I'm looking for, x times what is 4x cubed? Well, that would be 4x squared. Multiply 4x squared times x minus 1. That would be 4x to the power of 3 minus 4x squared, and we subtract. This becomes 0. Negative 14x squared minus a negative 4x really becomes adding, which leaves me with negative 10x squared. Bring down the next 2 pieces, which is positive 2x and plus 8. Next is x times what is, oh man, I'm running out of room. I knew I was going to regret this. Okay, so x times, what is that, negative 10x gives me negative 10x squared. Negative 10x squared. When I multiply these, I get positive 10x, and I subtract. And when I subtract from there, I end up getting 0, and then 2x minus positive 10x would be negative 8x. So negative 8x, and then I'm bringing down this plus 8 here. Sorry if this is too messy for you. The last step here is x times what is negative 8x. That would just be negative 8. Negative 8 times x minus 1 gives me negative 8x plus 8. I subtract. I get no remainder. And so now I use this top answer here to fill in all my coefficients, 6, 4, negative 10, and my constant of negative 8. So there's my answer for number 4 after using long division. Tasia used long division to divide. Show what it would look like if Tasia had used a diagram. So this is good. This is us showing that we know both methods here. When we're dividing, right, this inside is what we get on the inside of the diagram here. The number on the outside here is what we get over here. And then the inside, or sorry, the top ends up getting our solution here, which would be, negative x squared, 6x, and negative 8. As we were going through the diagram, all the things on the inside would end up adding up to what we get underlined in red there. So this one here has to be the first term goes in the first box. Then the negative x squared multiplied by 2 is negative 2x squared. And then x times 6x is 6x squared. And so what I want everyone to see here is that we can kind of see what we're getting here is that our original term, which was 4x squared, it being broken up into negative 2x squared and 6x squared, we see it in the diagram. We also see it in long division. Same idea with like the next one here, which I'll do in purple, is negative 8x, which is 6x squared. This becomes 12x and negative 8x. So when I start with 4x here, it's broken up into positive 12x and negative 8x. And so you can kind of see where the diagram and the long division kind of match. And then when we figure this last one out, we end up just getting negative 16, which, again, because we are getting no remainder, that's just our bottom right number. All right, number 6, we got x minus 1 as a factor of this other term. Select all the other factors. So let's, again, the first thing that I look at before I even start here is that each term has x in it. So my recommendation is hopefully you start seeing this pattern is that if you see a polynomial like this, the first thing that you can do is you can take out a greatest common factor of x. And so really it's going to be x times, and then when I pull that out, I end up getting whatever is left over. And then now I can actually do the division where I divide, this part here without the x now, divided by x minus 1. And so I already know that a is a solution because I've already factored out that x. Okay, so next up, what I have here is I can divide this by x minus 1. So I'm going to do that again just to practice long division. I'm going to go ahead and do it that way here, x cubed minus 3x squared. I'm hoping from the last homework you got enough practice with the diagram. In the end, you'll be able to choose whichever one you like the best. But for this one, we're going to practice with the long division. So x times x squared gives me x cubed. I multiply, I subtract. So this becomes 0. Negative 3x minus a negative x squared gives me negative 2x squared minus 22x plus 24. X times what is negative 2x squared? That would be negative 2x, which when I multiply gives me positive 2x. Now I subtract and I get 0. I get negative 24x. And then bring down the positive 24. And then this is looking good because next is negative 24. Oh, I should do a different color here, actually. Let's do orange. Negative 24 is what multiplies by x to get me negative 24x. When I multiply it by x minus 1, negative 24x plus 24, I subtract and I end up getting no remainder. And so now in light blue over here, I've factored again to get x minus 1, x squared minus 2x minus 24. And again, when I look at like my possible solutions over here, they're all just binomials, only 2 terms. So I'm going to try factoring one more time by using my diamond and box. First term, first box, last term, last box. Negative 2x has to split up into something that multiplies by negative 24x squared, negative 6x and 4x. Oop, that's 4, and that's negative 6. And so my final factored form, x minus 1, x plus 4, and x minus 6. And when it's fully factored, just a real quick thing to note is that I have all of these x's as single digits, no exponents in there, but there's 4 of them, which matches what I started with, x to the power of 4. So I have 4 different factors here. X minus 1 isn't shown in my answers, but it was given to me originally. So the other 2 answers, x plus 4, which is E, and x minus 6, which is F. Problem 7 to 8, use the given factor to rewrite each standard form polynomial in factored form. So for number 7, we are given a factor x plus 2, and we are asked to put it in standard form. Sorry, we're asked to put it in factored form, given what is standard form. So do some division here. Again, I'll split this up. I'll do one in the area model, and then I'll do one with the long division, just because I want us to get practice with both. So in this one here, x plus 2 has to go on the outside for factored form. First term, first box is x cubed. Then this has to be x squared to get 2x squared here. These 2 terms have to add to negative x squared, so that has to be negative 3x squared, meaning that has to be negative 3x. Multiplied by 2 is negative 6x. This term and this term have to add to negative 4x, so that has to be positive 2x, which makes this just 2. 2 times 2 is 4, which is good because this last term matches my last term here. So it ends up giving me x plus 2, and then x squared minus 3x plus 2. Let's just really quickly double check to see. Oh, just as a heads up, I didn't use this because I didn't have enough. I made it too big, but I need to see if this part here can be factored again. So real quick, first term, first box, last term, last box. 2 things that negative 3x breaks into that multiplies to 2x squared would be negative 2x and negative x. So it does factor more. X, negative 1, negative 2. And so my final solution here in factored form is x plus 2, which was a factor we were given, x minus 2, and x minus 1. Again, when we look at this, key thing to see here is that's x cubed, and I ended up finding 3 different factors. All right, number 8, we're going to use some long division to help us with this one. I'm dividing the standard form by the given factor, so x plus 3. How many times does that go into x cubed plus 4x squared minus 17x minus 60? So x times x squared gives me x cubed. When I multiply, I get x cubed plus 3x squared. I subtract, and I get just x squared, and then I bring down the rest. X multiplied by just a positive x gives me x squared. When I multiply that, I get x squared plus 3x. And then I subtract 0. 17x minus 3x is negative 20x. Bring down negative 60. And x times negative 20 gives me negative 20x. When I multiply, negative 20x, what is that? Minus 60, which is good. I subtract those 2 and I get a remainder of 0. So now I am at x plus 3 in parentheses, x squared plus x minus 20. And now I'm going to check to see, does this term right here, can I factor that using the diamond and box? So box here, first term, first box, last term, last box. X splits up into 2 things that multiply to negative 20x squared, which would be 5x and negative 4x. 5, negative 4. And so yes, my final solution here, x plus 3, which is what we were given, x minus 4, and x plus 5. So my cubic function gave me 3 different factors. All right, number 9. Place an integer in the box to make the statement true. Use integers 0 through 9 no more than once. So a couple things that I know about the way that these work. So I'm really just dealing with two binomials multiplied together, which will give me, some trinomial here. And when we're doing that, a couple of key things to remember here is that like the first term here is always given to us by multiplying the 2 first terms here, as well as the last term here is, the last 2 terms multiplied together. And so when I do this, I'll start off with like kind of simple numbers here, but when I'm looking at this, I know I'm going to be multiplying something by 2 and then 2 again. So what I mean by that is that if I make this 2x times 2x is going to be 4x squared. Then if I were to make this, let's say 3 times 2 is going to give me 6. And so really what I've kind of found out is I know the 2 things I'm multiplying now. I have 2x plus 2 and then 2x plus 3. And when I multiply those together, I end up getting, let's erase this real quick. What I end up getting here is 4x squared plus something plus 6. And so I just need to figure out what's that middle term. So in this case, I end up getting, 4x plus 6x, which is 10x, which means that fills in those 2 spots right there. Again, I know it had to be a double-digit number because of how many boxes they gave us. So just kind of using what we know about multiplying 2 binomials. All right, spiral review. Number 10. Is 9 a factor of 181? Well, a couple different things. First of all, like you could just try dividing it, right? If you had a calculator, or if you just like were doing long division, you'd see that 9 goes into 18 twice. You'd subtract, bring down the 1, and then you'd have a remainder, which means it's not a factor. It's not a factor if it has a remainder. The other way of thinking about it is that, like, for example, I know that 9 is a factor of 81, but it's not a factor of 100, which is another reason that's not. Okay, is 9 a factor of 1242? Again, a couple different ways of doing this. I could just try and divide it and see if it comes out nice and even. So it goes into 12 once, goes into 34, what is that, 3 times 27? No, that's not right. Yeah, okay, actually it is. And then that's 7, bring this down, and then I get 8. And since I have no remainder, yes, it's a factor because when I divide them, I end up getting a even number. I don't have any remainders. So for number 10, it was no. For number 11, it was yes. Kind of a longer video this time because I was doing a lot of division and long division, but the process is a good one to remember. You can choose which method you like come test and quiz time, whichever method works best for you. So when dividing or trying to factor, being able to use the area model or long division will be helpful. See you on the next video.